Now I will show you an item to create a symbol. Just one click and you can see the symbol created. Left side is input, right side output. In-out pins are both placed on both sides. And now we can create a box sheet, and its symbol also create here. Box sheet information can contains company logo, library cell name, revision, and modification time, creation time. And here is the designer information. So after we create a symbol, then we can create a test bench by click create bench, and then it will create an instance of this block and connect all the terminals and use the terminal length as the let length. Also, it will create a stimulus for inputs, because here Y is output, so it does not have any stimulus. Now we change the inputs to a pulse. We pulse and use some design variables to control the frequency and the voltage level. And so now the bench schematic is ready. Then we will launch ADE and HLSim to do simulation. Just one click, and here we already have a sim file set it already. And the process to set up a sim file, firstly we need to set up corners. Corners, we can clear and click add. It will launch model selector to select models. You can predefine corners, typical, apply, fast, slow. Okay, we choose the 3 corners, and we can modify it. We don't want typical. You can see. Also, we can restore the saved value and select corners can be saved to files. The file name is here, and we can save and load the files. We can have a look of the file contents. The files, the model corner file has a list of the model files and the sections. So this is example model corner files, and then we click OK. And then we will set design variables. So here it is already set it. We can remove all corners and click all corners, and remove all temperature, all temp. So now we have 2 VCC and VCCB. We set VCC 2 has 2 values, 2 volt and 4 volt, but VCCB can be 2, 3, 4. We can set some filter. Here is the example: VCCB larger or equal to VCC. So because these 2 variables will be nested, cross coupled, so we can see the final effect of the filter later. So we can see corner has 3 corners, 2 VCC, 3 VCCB, and 3 temperature. Totally should be 3 times 3 times 3 times 2 be 54 rounds. Now we can see there are only 36. The reason is because we have filter. We can see when VCC is 2, VCCB can be 2, 3, 4, but when VCC is 4, VCCB can only be 4 because filter needs VCCB larger or equal to VCC. So this is the usage of filter. And then after set the design variable, we can set the analysis. Here we set chain analysis, then a DC analysis, and then we will change the stop value, because now we will do the VIH simulation, so we can just set the stop value to be fixed value to forward. But sometimes you want the stop value to be VCC, then we can just change here to be just add now the stop value can be VCC. So it's fairly easy to change. And after adding analysis, we will add some calculations. This is test bed for VIL test. So we will cross the output to the half VCC, and the VIH is the first cross point, and the VIL is the second cross point, and hysteresis is the data value. Here we can see allow use design variable in code. This is user calculation, and VCC is design variable. So if we check this checkbox or only check this, then we can use design variable as skill variable directly in the calculation expression. Also, you can see here VCC is design variable. We can use it as skill variable directly because we can allow use design variable in all, including analysis. So user code can be, there are 1, 2, 3, 4, 5, 6 type of user code design variable can be used. Analysis and user code before run, before all, after each, and after all. Also, user code design variable can be used in calculation. Now we will see how to plot. Here we firstly we can click what signals we want to save. Let's do it again. So firstly we need to remove all. And click add. Select A and Y, escape. Now and Y will be in the signals list. And then we will add the plot window. So as you know, waveform window has a title. So here the waveform window title can be set with various settings. So this means the cell length This means the bench test, which is now the bench test. Bench len is DC. So this is the option len. This is normally no use, and we can also support some other format. P means process corner, V means VCC, T means temperature. So this plot window the title will be cell len and the test len and then option len, and we can add sub window for this waveform window. Sub window uses will grouped by VCC value and the temperature value. So different VCC or different temperature will have different sub window. Now we will add signals into sub windows. We select sub windows and then we select all the signals, and then click add. So we can see the strip value. If we want to put different signals into different strip, we can just here we can select a sub window and then click strip. Now signals will be in different strip, and also the signal title. We can set signal title here. The I means the index. Here we can see we can have various format for the signal titles. For this one, we can even set the design variable. Here you can see design variable and the scale variable or environment variable here. Okay, so this is for the test DC, and when you set all things, you can then save the same file, and also you can new test. Now we have test DC and we want AC test. Click new. You can see DC change AC. So if we want to remove AC, then choose AC delete. Now we only have 2 tests. This is the preview wrong string field. We can the format for this field is first we need to specify the wrong numbers, and with a slash, then we need to specify the test number. So we can see 1 means the index is from first, and 0 is the last one, and the 1.0 means all wrong numbers. So if we want to choose all the odd numbers, then we can just add the step. You can see, so all wrong number is odd number. If we want an even number, then we can change the start number to 2. So, an even number, and you can see this is the test number. So number 1 test is always the len is always active, and number 2 test here is DC test, and number 3 is transient test. So also we support the negative number in this negative number. So 0 means the last one, -1 means the one before the last one. So last one is 36, so minus 1 is 35, and minus 4 is 32, and we only need the odd numbers here. So if we start change the test from 2 to 0, then active will be removed from the preview. So we can have a run to see the effects. So if you want to plot, you need a checklist. If you want to log, you need a checklist. So we can see for a change in the simulation, so waveform, the waveform window title changed, so it will have different waveform window. But for the DC simulation, we'll have different sub window. The waveform window is same. So why we have no waveform? Because we choose wrong result type. We need to change to get data or DC. Now let's run it again. We only run DC test. If you run the current test, you need not to specify the test range. We just run it. Okay, now the waveform is okay. Okay, that's all.